All right, so let's look at this problem. It's a truss, as you can see. It's got a pin and a roller for supports, and this particular problem wants to find all the forces. So we're going to probably use a combination of method of joints and method of sections. So let's start. Usually a good place to start a problem, especially these truss problems. Let's find our reactions. So I'll assume that I have a reaction in the X and Y directions at A, or a pin, and since E is a roller, I'll assume that I have a reaction in the Y direction, up. So let's find those values. So a good place to start is to sum moments about either A or E. I'll do A. So right-hand rule for my sign convention of my moments, and I'll sum all of those at A and make sure they're in equilibrium, equal to 0. So let's look at all the applied forces here. They're all there's 2 6-kip forces and a 3-kip force. About A, what kind of moment do they create, positive or negative, with right-hand rule? Anybody know? Hopefully you know.
The downward force?
Yeah, all these forces, what kind of moment do they create? Positive or negative? Negative, right? So first one, I'll start here and move to the left, so that'll be 6-kip force with a moment arm of 20 feet, minus 6 kips with a moment arm of 40 feet, and then minus 3 kips with a moment arm of 60 feet. And then I have my reaction at EY. What kind of moment does that create about A? Positive, right? And that has a moment arm of 60. So what's EY equal to? Anybody get that? Let's see. It would be 2, 4, 3, 6, 9. Anybody have that? I'm guessing. Negative 5? No, it's not negative. 5?
I got 9.
I think 9. Yeah, I like 9 better. Anybody else get 9? Anybody?
I got 9. Yeah, I got 9.
Oh, you got 9? Okay, 2 9s. I'll go for that. I like 9. So then I can sum forces in the Y direction. Make sure they're in equilibrium. So I have AY acting up. I have EY acting up. And then I have all these forces here along the top chord acting down. So I got minus 6, and minus 3. So that's what? AY is 6? Is that right? Looks like it. And then we can quickly sum forces in the X direction. This one shouldn't be hard to do. All we have is AX. No other applied forces, so AX is 0. Okay? So what would be a good strategy? Where should we start? We've talked before about zero force members. Are there any in there? Yeah. There's what we call a case 2 at G, so I can write from inspection that I have a zero force member, and that would be the force in BG. And just to keep track of that, I'll put a little tick mark here. It's 0, but just mark it. Now, what does that also say? That AG is equal to what? Whatever the force in FG is. So this is not 2 unknowns, this is 1. So if I find, say, AG, then I know I have FG. Okay? That's all the information I can extract from that. I'll go ahead and underline that too. That's something that we probably want to remember. So let's think about our strategy. A good place to start method of joints is any place where there's two unknowns. That would be A and D, and then we'll work from there. So I'll just do that. Let's start with, just to go alphabetically, I'll do method of joints at A, and then we'll do method at D. So if I start at joint A, so there's my pin at joint A. I have AY, which is up and equal to 6 kips. AX is 0, so nothing's there. And then I'm going to assume tension forces in AG and in AB. And while we're there, what's the slope of AB? Well, it looks like the run here is 60 over a change in height of 30. So that's what, 1 to 2? That seem reasonable? So I like to do the hypotenuse. What would be the hypotenuse of that side? 2 squared plus 1 squared is 5. Take the square root of that. So this should be square root of 5, right? Not a very common one, but it's 1 to 2 to square root of 5. All right, so now applying my two equations of equilibrium to this free body diagram, what should I do first? Some force is X or some force is Y? Some force is in the Y direction because only one force has a component in the Y direction. Cool. So let's do that. So I'll assume up is positive. Well, some forces in the Y direction. Make sure they're in equilibrium. So the Y component of this will be 1 over the square root of 5. It's acting up. What else do we have? 6 kips is also acting up. So what is the force in AB? It looks like it's going to be negative. Whatever 6 times the square root of 5 is. What's that? 13.42. Anybody else get that? Seems reasonable. And then now I can sum forces in the X direction. And in this case, I'll have the X component of AB, which is 2 times the square root of 5. And that's force AB, and that's to the right positive, and also positive is the force AG. So I can plug my value in there, which should give me AG is 12. Is that what you guys got? The square root of 5's cancel, and there was a 2 there, so that's how I got the 12 so fast. And since we have AG, we also have FG. So let's mark the ones I have now. So I've got this one, and this one. So we've got 4. And we have 1, 2, 3, 4, 5, 6, 7 more to go. Not halfway yet. I'm going to suggest that we go ahead and go up here to D and find CD and DE. That looks like an easy place to start. So I'll come down here and say, let's look at the joint D. So I'll draw a free body diagram of that. And I've got a 3-kip force applied at D. I'm going to assume tension in force DE. And I'm going to assume tension in force CD, and the slope of that line is the same as before, 2 horizontal to 1 vertical. So the strategy here is going to be pretty much the same at A. We'll except that you'll notice that CD has an X and a Y component, and DE only has Y. So we're going to sum forces in the X direction first. So summing forces in the X direction, make sure we're in equilibrium. So in the X direction, what do we have? We have 2 over the square root of 5. That's negative 4 CD. And what else do we have? Nothing. Right? So that means the fourth in CD is 0. Now that technically makes it a zero force member, but it is not a zero force member in the way we do it by inspection. It just so happens that with this load applied at this joint, this element has no force, and pretty much all the 3 kip is going to be handled by DE. And we'll find that when we sum forces in the Y direction. So in that case, we've got negative 3 kips acting down, minus the force in DE. So when I solve for the force in DE, I get minus 3 in compression. So that means we have this one, and we have this one. So how many more do we need? It's like 1, 2, 3, 4, 5. There's a lot of different ways we can go from here. Let's just examine, for example, if we go to the joint at B, can we solve for forces there? Well, originally no, because we'd have 1, 2, 3, 4 bar forces. But now we have 2 of those, so there's only 2 unknowns at B. We could solve for them. Might be a little bit of a challenge because you'll notice that both the elements have both X and Y components. So those would have to be solved simultaneously. Let's see. What about joint F? Could we go to joint F now? Well, it looks like it's got 1, 2, 3, 4 forces, and we only know 1. So that's 2 equations, 3 unknowns. F's not a good place to go. What about C? Pretty much the same. There's 1, 2, 3, 4 bar forces. We only know 1. Again, 3 unknowns, 2 equations. We could go to E, right? Originally there was 1, 2, 3 unknowns, but now we know 1, so we could get some stuff here at E. And I think that's a good place to go. So let's try that. I kind of did this in the wrong order. I'm gonna go back and number these 1, 2, 3 for kind of at the order that we're approaching them. Because if you come back and read this later, you may try to read it like a book, and you would go from A to E, and there'd be a problem because it wouldn't work without the results from D. So we'll do it kind of like you're reading a newspaper in columns. 1, 2, 3. So here we are at E, and we have EY, which is acting up of 9 kips. We have the force in DE, which we just happen to know. We have the force in EF, and we have a force in CE. And now what is the slope of that particular one? Of this one? Well, it goes over 20 and it goes up how much? Also 20. Because it would be 30, 20, 10. So that's 20, 20, so that's 1 to 1. Now remember, I'll go ahead and indicate that here. We know DE. So with that as a background, should we sum forces in the X direction or Y direction first? Y direction. Because CE is the only one with a Y component. So we'll assume up is positive, and we'll sum forces in the Y direction, make sure we're in equilibrium. So let's start. We have So this would be 1 over the square root of 2. That's the y component of CE acting up. We have the force in DE acting up, and we have this applied force EY acting up. Now remember that DE we found was -3. So we're going to put -3 in here. Right? When we do that, this term here becomes 6. And what's 6 times the square root of 2? 8.48. So I think that is our value. You might want to check it. If you put it in here, I think it works out okay. Now that we have the CE, we can go back now and sum forces in the x direction and find EF. So let's start. EF is to the left, so that's negative. And then we need the x component of CE, which is also negative. The x component is 1 over the square root of 2 times the value FCE. So it looks like that FEF is going to be 6. The same number you just got divided by the square root of 2? Yes?
Yeah.
And it's positive. CE was negative. That makes this positive. Yeah, that should be positive. Is that okay? Does that make sense? Does it make sense that EF would be positive? Positive is tension. And I think you'll find with all the loads acting down in gravity that all the bottom chord elements should be in tension. And we already found AG before. Where was it? There it is, positive. So now we have this one and this one. So what are we left with? We've got this top chord member, this vertical, and a diagonal. How best to do those? I don't know. That's a good question. Now it gets a little challenging.
Would it be bad to do like method of sections?
No, I think that's a good idea. I think what I'm going to do now is I'm going to do a method of sections right here. Okay? And when I do that, that's going to allow me to find these two, hopefully fairly easy. And then I'll just be left with this vertical. And this vertical, I don't know, we could always go back and cut another section and try that. But for now, let's just try this. So I'll call this section 1. And let's see if I can squeeze it down in here. So there's 4. I'll put a little line here so we have some space to see it. I'm going to work the left-hand side because it's a little easier. So I'm going to try to draw that right here. So that would cut and open up this force, which will be the force in BC. Also, I would see the force in BF and the force in FG. Then I have my reactions. AY 6 kips, AX is 0, and then I have an applied 6 kip load at B. What else? I'm not going to try to squeeze the geometry in. But let's do this. What is the slope of this guy right here? I think we've already found that before. That was 60 to 30, right? So that'll be 2 to 1. I obviously don't have this one to scale. We're looking at this guy. So it has a horizontal change of 20 to a vertical change of 10, so that's going to be 1. Oh, it's also 1 to 2. That's interesting. Okay? Now let's keep in mind that I know FG. We know that FG is equal to AG, and we found AG to be equal to 12. So these are the two unknowns that we're working with. Is there some place we can go and get one of these, one equation and one unknown summing about a particular point?
The moment about F.
The moment about F. So my scale won't look right here, but I'll try to bend it. But at some point out here, they would pass through F. Now, I want to show you this too. So if I go vertical, then and move my force. Remember, this force is valid anywhere along the line of action. So what I'm going to do is I'm going to slide it up here so that I'll have a horizontal and a vertical component. See that? And about F, you'll see the horizontal component creates no moment. I'm sorry, the vertical component creates no moment, but the horizontal one does. And we know the horizontal one is 2 over the square root of 5 BC. And then we know this height from F to C is 20. So we have our dimensions. So first we'll sum moments about F. And when I do that, this force creates positive or negative moment about F, according to my sign convention. Negative. So I'll have minus 2 square root of 5 FBC times its moment arm, which is this height, which is 20 feet. And it's being balanced by the 6 kip, which creates positive moment, and has a moment arm of this distance, which is 20. And the reaction at A, which is creating negative moment, and its moment arm is the distance from A to F, which is 40. So what is the force in BC? I don't think I'll be able to knock this one out in my head. 6, 12, 6, 3. 3 times the square root of 5, I'm guessing? Whatever that is. No, I did that wrong. It should be negative, too.
Maybe 6.7.
6.7? Maybe? We've divided everything by 20. This becomes 6 and this becomes 12, so that's negative 6. So that's the other side. 6 divided by 2 is 3. 3 times square root of 5? What do you get, Miss Petrid? You're shaking your head.
Yeah, 6.7.
What is it again? 6 point what?
7.
7 point?
6.71.
Oh, 6.7. That seems reasonable. How do I get BF all by as lonesome? Can I write one equation in BF? Is there some place where BC and EF are concurrent? At A. So let's do that. I don't know if I can squeeze it in here, so I'm going to have to switch. Well, if you look at the line of action of BC, it can go anywhere through here, right? So it actually passes through A. And then you look at FG, it can go anywhere through here, and so it also passes through A. So if I sum moments at A, the only force that's left that creates moment about A is some component of BF. In that case, I'm going to let BF slide all the way down to F, and I'll have a vertical component and a horizontal component. And you can see the horizontal component passes through A. So I'll just have the vertical component times the distance from A to F, and that's it, balanced by the force at B. But I've run out of space, so I'm going to have to do this on a second piece of paper. So let's see if I can do that. I'll have to do it up here, I guess, so you can still see my chart. So I'll start over here. So I will sum moments about A. So as we just discussed, the force in BC and the force in FG pass through that. So now I'm looking for the vertical component of BF, which is what? It's 1 over the square root of 5. And it's acting down. This is a little awkward, sorry about that. And the moment arm from A to that is 40. And what else creates moment about A? The 6 kip force, and that creates negative moment again. And it has a moment arm of 20. So we should be able to solve for the force in BF. It looks like it's going to be negative 3 times the square root of 5 again. 6.71. Okay, so that gives us this one and this one, and we're only left with this vertical. What's our strategy for that? This is going to be kind of tricky. If you go to do a joint at either end, let's say C, you've got 1, 2, 3, 4 forces to keep up with, and they're all. This is a Y component only, but so everybody else has Y components. You could do that. You could do the same thing at F. F might be a little nicer because, again, you're looking for CF, which is Y, and only one of your forces has a Y component. So I think that's what I'll do. So I'll go, I guess let's see, 1, 2, 3, 4. So this will be my 5th strategy. And we'll do a joint at, what did I say? F. I'm going to have to do some moving around here. So let's see, here's F. And this is the one I'm looking for. The force in CF. I've got the 2 forces acting in the bottom. Force EF, force FG, and then one here on the diagonal, which is force BF. And we know that the slope of that force is 1 to 2. That looks like a really bad place to go, but remember, we know this one, this one, and this one. This is the only one we're missing. So as we just discussed, summing forces in the Y direction seems like a good thing to do. So let's do that. We'll sum forces in the Y direction. So I have the force I'm looking for, CF, acting up. And then the vertical component of BF is 1 over the square root of 5. So it looks like the force in CF is going to be whatever that is. And we saw for BF before, didn't we? Where is that? Way back at the beginning? No, we just saw for it here, sorry. Negative 6.71. So plug that in there, and what do you get? Divide that by the square root of 5. Do you get 3? And it's negative. Okay. That was a long problem. On the timer, it's been 30 minutes, so this is not a problem that I expect you to do on the exam, but I thought it was an interesting one to kind of summarize what we've talked about in truss analysis, because as you can see, it's a combination of some joints, maybe some method of sections. There would be other opportunities to do method of sections if we had chosen to earlier in the process, so we could have done that also. So any other questions before I stop? Okay.